Excellent. Right. Okay. Well, look, we're now just 3 minutes past the witching hour. So what I not an awful lot to say here. You've obviously read Neil's intro. A lot of you will know Neil. Barry, would you like to add a bit of flesh to the bone? You know Neil far better than I do.
Yes, sure. I first met Neil around about 1983, 1984, when he gave a talk at the Portsmouth Club. He hadn't long been making the engines at that stage, and I have to say it was a riveting talk back then, and I'm sure with all of the experience and trials and tribulations that Neil will have had since then, we're in for a really good evening. And Neil's an all-round aero modeler. He is interested in the whole gambit, and he has a very progressive view on the hobby as well, despite his aging years. I don't think he'll mind me saying that. So that's a little bit of flesh on the bone from me.
Thank you. Neil, I think we're gonna flip you over to speaker view and let you talk to the masses. Neil Tidey, thank you very much indeed.
Well, thank you everyone for joining in, and I'm going to start right from the beginning with a little picture of the JetX box. Now, my aunt, when I was about 14 or 15, gave me a JetX car, and this was quite remarkable because you had a brick at one end and a brick at the other end and a piece of string in between. And this car actually ran along this sort of straw, guided by the string. And so that was on the pavement outside my house. And so that was the JetX motor. Now, that car didn't last that long. So we ended up actually by putting it into little homemade chuck glider type aircraft, you know, the Vickers Valiant, the Venom, Hawker, Hunter, and that type of thing. Little homemade aircraft, own design, and that was really the start probably of my aero modeling career. From then, I got an Alban Dart, which is this little engine, and I think this is the actual one that I had. It was a green head one, and that was clamped onto the table in the kitchen, and after about half an hour of flicking, this eventually fired up and filled the kitchen with smoke. And that was the last time I ever ran an engine indoors, or was allowed to run an engine indoors. We had a wonderful model shop down in the lanes in Brighton, where I lived, called Arthur Mullet's. And you went in there and you got this sort of smell of glue of fuel, and it was absolute magic, and boxes of stuff. And so that started off things. So with the little Alban Dart, that went into a number of different little free flight models, and eventually ended up in a Mercurian Knight, which was Ray Malmstrom's design, little flying saucer thing, and that was my first control line model. I then got a motorcycle, which meant, of course, mobility. And so I joined the Worthing Bald Eagles at that stage, and we went into control line in a more serious way. And that meant in 1964 and 1965, I actually reached the Nationals finals, and lost in both cases, but never mind. In those days, we had an entry which was restricted to 128, and that was because of the amount of rounds that you could put in. I don't think they get quite that sort of entry nowadays. So that was the start there. I then bought a house and renovated that and moved up to Leighton Buzzard, where I am now. And that meant probably about 4 or 5 years of getting out of the modeling side, but it was still within me. And so started off on radio control there. I had a Sky Leader set, and this was obviously on 27 meg, and learnt to fly. Joined the Buzzards Model Club. Well, I was one of the founder members of that, and also the Buccaneers, which is still running, and flew also up at Ivinghoe Beacon, which is one of the places where, of course, I saw Sean Bannister, who did the meeting last week. And there was a wonderful guy up there called John Hennell Nash. He was an opera singer, and he did Saturday night at the opera or something. And his voice boomed out over the Chiltern Hills. Lovely sort of guy. Then coming on a bit further from that, I met Reg Cross, who had a factory in Hemel Hempstead. And Reg was interested in engines, and he was interested in making a product which could actually be made in his factory. The factory made components for air tools, which with an air tool, if you drove it, instead of actually putting air to it, you put a motor onto it, it became a compressor. And of course, that led to the idea of supercharging. And one of the first things I can show, which is a wreck of things, and this was actually one of the air tools which we grafted onto the back of an HB 61, and it virtually doubled the performance of the engine. And we thought, this was terrific, but the fuel consumption was absolutely horrendous, and it really was not going to be a viable proposition. But it was a very interesting project. So that was that bit. Then the next thing, of course, was to start thinking in terms of making a four-stroke engine from scratch. I looked at all the engines which were about, and we had, if I can just dig out a couple of bits here, a guy over in Luton was making a converted Merco 61, and that was the cylinder head which was made for it, and that had a bathtub type combustion chamber. And at that time, OS, of course, has started making engines, and they had the same thing as was incorporated on this, and that was like a touch hole. So the plug was slightly remote, and so it worked. Well, we're not quite sure why it was done that way, but this is a very simple combustion chamber, and it's very much, of course, of a model type cylinder head. So looking at these model engines, we decided, well, that really isn't the right way of going. And so I started then looking at full-size engines. So if we can just get onto the full screen part and some pictures which I've got, I'll go through and describe some of these things. That's a picture of a laser V-twin, and we'll talk about V-twins and engines like that later on. Let's go on to the next slide. Can we go to the next slide? That's it. So how does the four-stroke engine work? Well, each stroke is the piston going up, and then the piston comes down, piston goes back up again, and it comes down. So those are the four strokes of it. So if we start looking at the first part of it, the inlet valve is open, the piston descends, it brings down fuel and air into the cylinder. At the bottom of the stroke, the valve shuts and the piston goes up, compresses the mixture, which then, of course, is ignited, forcing the piston down. And then, of course, at the bottom of the stroke, you can see the last part there where the exhaust valve opens. And with the exhaust valve open, the gases then escape. And you go back to square one again to the first stroke. So four-stroke engine, that means two strokes of the engine, or two revolutions rather of the crankshaft. It's not quite as straightforward as that, because valves don't suddenly open and suddenly shut. So if we go on to the next slide. Now this is very simply showing a simple simple cylinder engine, single cylinder, and there is a counterbalance weight on that. Now, the problem on a single cylinder engine is that the counterbalance weight will counteract the weight of the piston and the conrod when the piston is in a vertical position. But when you're halfway down, the counterweight is sort of trying to put itself out through the side of the engine. So you cannot fully balance a single cylinder engine on that basis. So it's a compromise. And you normally get something like 2/3 the weight of the piston and cylinder, which is the actual counterbalance weight. There is a way of overcoming that, and that's by putting a geared counterweight on the other side, so that when one cylinder, when the counterweight is out on one way, then you have a counterweight on the other side as well, so the thing sort of counter rotates. But that puts a lot more weight, of course, onto the engine, and of course more complexity. Let's go on to the next slide. With a V-twin, a 90-degree V-twin, you overcome this problem to a degree, because when one cylinder is piston is at top dead center, the counterbalance weight is actually at exactly opposite. And as the engine rotates, you end up with the other cylinder being counterbalanced by the weight. So you can get very good primary balance on a V-twin. That's on a 90-degree V-twin. Now, the problem on there, of course, is that the firing strokes are not quite opposite. And so you do get a certain amount of vibration, of course, because of that. Let's go on to the next slide. This is a typical timing diagram. And valves, as I mentioned, don't open and suddenly shut. There is an acceleration of the valve from the closed position, and then, of course, it decelerates to the full top part. Then you have a dwell period, and then the acceleration of the valve goes back down again. And so you accelerate and then you decelerate as it comes back into the closed position. So with the opening, you normally start opening the exhaust, as you can probably see on the diagram, at 70 degrees on this one as it's shown, before bottom dead center, so that most of the gas has actually pushed the piston down. So you've got most of the energy there. And so by opening it, it will be fully open, probably past bottom dead center. But a lot of the gas will already have been, will be escaping through the valve. So then you get to the point where the engine, of course, opens up with the inlet, and the inlet will start opening before top dead center. And the reason for that is that hopefully the exhaust will actually be pulling some of the inlet into the cylinder. It depends on the design of the cylinder head. And you end up with a situation where both valves are fractionally open at top dead center. And we'll come across that one actually in a moment. The overlap does possibly give you a little bit of fuel going into the exhaust side. So that can be a problem. The long overlap does make a big difference, of course, because if you have too much of a lap, then you lose the efficiency of the engine. Let's go on to the next one. The valves, as I mentioned, they don't suddenly open and suddenly close. Now we've got a situation here where you've got a dotted line underneath the other line, and that is where you've got a fast opening cam and not a huge amount of dwell. With the faster opening cam and a longer dwell, you can get more fuel in, more fuel and air in, but it makes the engine a little bit more sensitive and doesn't give you quite the same performance level in terms of efficiency. So the cams are quite complicated. Let's go on to the next slide. Now, the next thing that came on were the different types of combustion chamber. A lot of the older engines had what we call a side valve layout, where the valves were on one side, very convenient from the point of view of driving a cam to the valves, but there is a very, very long distance between the plug and the width of the cylinder head. So that means the flame spread is going to be slower. When we come on to the bathtub, this has actually got two slight squish areas on either side. Now, you're probably familiar with this, actually, if you're familiar with two-stroke engines. And the idea is that as the piston goes up, it forces the gas towards the center of the combustion chamber. So you get a fair degree of turbulence on that. The valves on the bathtub chamber can be vertical, which makes things nice and easy to make. So that's another thing which is quite useful. The BMC, the old Morris 1000 engines, they were a bathtub type, and a lot of the OS engines also have a bathtub shape. Then we come on to a wedge chamber, and that's got quite a large squish area, which is shown actually on the right-hand side here. The valves are at an angle, which helps the fuel going into the combustion chamber, because it doesn't have to go through quite the same angle. In other words, on a bathtub, it goes through 90 degrees. On this one, it goes through a much shallower angle. You've got the squish area, and also there's a small squish area on the left-hand side. And so this gives a turbulence in the cylinder. Then we come into the bowl in the piston type layout, which is almost an inverted bathtub chamber. This was used actually on quite a number of Ford engines, but the problem is that the piston is much heavier because you've got more mass of it, because you've carved out the bowl. The final one is the hemispherical head, which is really the main performance type of cylinder head. And you've got here the valves actually at angles, so it gives you a nice shaped combustion chamber. Sato engines tend to use this type of head. Let's go on to the next one. Now we come on to the full-size engines, and this is the Gnome Rotary engine. We've got rotary engines where the cylinder actually rotates around the crankshaft. This does give a huge flywheel effect, as you can probably imagine. It gives very good cooling, and it probably also gives a certain supercharging effect because the air and fuel are taken in normally through the crankcase. Now, this particular one was quite interesting because it's got a valve in the top of the piston. And so as the piston goes down, the valve opens and allows gas to go into the combustion chamber. And that's it. And as you can see on the top there, there's another valve, and that's the exhaust valve. So you get quite a good flow through there. The disadvantage, of course, is the simple weight of the engine going round. And that is where the engine failed at the end. There was a limitation as to how much weight you could actually put round. You did end up with two rows with the Bentley BR2 engines. This goes back to the First World War. And the manufacturers of the Gnome engines, they made an absolute fortune because the engines were very efficient. From the point of view of manufacturing, the thing which I found interesting was that the cylinders were made from a solid billet of steel, and the fins were machined down to a 1/16 of an inch, or 1.5 mil. Quite amazing when you sort of think, this was done with machinery which they had in those days. And the machinery was probably driven by a steam engine outside the factory, and the overhead belts, and very, very crude. Let's go on to the next one. Now, this one is interesting. This is a green engine because it shows a number of characteristics. One is that it's a two-valve system where you've got an inlet and an exhaust. and it's got a push-pull rod, which is shown on the side there. Now, the problem on this is you cannot get any overlap, and so that reduces the efficiency of the engine. You've actually got quite a nice hemispherical cylinder head with it, and you'll probably also notice actually on there the valves. One is actually slightly bigger than the other one. We'll come on to that one a bit further. Let's go on to the next slide. This is the Chevy cylinder head, and this is actually a wedge type cylinder head with the valves at a slight angle. And again, you've got a squish area, which is shown at the top part there, which pushes the gas into the chamber. The plug is right in the middle. So again, the flame spread is kept to the shortest possible. And we've also got a situation here where the inlet valve is slightly larger than the exhaust. So that's the Chevy, which was a really high, well, is still quite a high performance engine. Let's go on to the next one. Now this is the engine, this is the cylinder head, which you find actually on most cars these days. And it's a 4-valve cylinder head. But it shows a number of characteristics. You've got a bit of a squish area on both sides. The inlet valves are slightly larger than the exhaust. You've got the plug right in the middle of the combustion chamber. And the advantage of using 4 valves is that as you open the valves, they're smaller valves, so they don't have to open so far as a 2-valve system to get the gas in. And generally, large valves, of course, will not run as fast as the 4-valve. And that's the cylinder head you'll find on most cars these days. And that would be an overhead camshaft. Let's go on to the next slide. Here we come onto a 90-degree V-twin engine. And this is actually water-cooled. And again, you can see the rockers and the springs. And that, again, gives you the cylinder, which is a semi-hemispherical type cylinder. So again, efficiency is good. The balance is quite good. It's an 8-cylinder engine. And the 90-degree V, again, works very well. The high-performance engines tend to be V engines. And when you think of the Rolls-Royce Merlin, that's a V engine. You can have a different angle between the V's and get the balance right, the more cylinders you put into it. Let's go on to the next one. This one is horrendous because this is a Napier Sabre engine, and it's what's called an H engine. So you've got a set of cylinders on top of the other one, driving a single crankshaft through gears. And this is a sleeve valve engine. And with the next, if we go on to the next slide, I think we'll see the actual sleeve itself. And this rotates in a figure-of-8 configuration with cams and gears on the front. Very, very complex, but it is very, very good from the point of view of performance. And the performance, the problem with it, of course, is that the sleeves are very, very complex. And you don't get particularly good cooling because you've got the sleeve in between the waterways. But it was an extremely powerful engine. I think it got something like 3,400 brake horsepower out of it, at quite a high speed, about the same, over 3,000 RPM. I've never actually heard one, but it was used in the Typhoon and 1 or 2 aircraft like that. Let's go on to the next slide. The Radial Engine is the way that the rotary engine rather progressed. And so instead of the whole cylinder, all the cylinders going round, the cylinder here actually is a sleeve valve. This is a Bristol engine. And again, you can see it's a double row. It's getting extremely complicated. And again, we ended up with a situation where there is a limitation from the point of view of a piston engine aircraft. The largest one, I think, really was the Pratt & Whitney corncob engines, they called it. And that actually had 4 rows of cylinders, an incredible thing. And each cylinder had 2 plugs. So just imagine doing a plug change on that. You know, you're changing 50, was it, what's 56 plugs, is it? Just on one cylinder. And this was one of the engines which was used in the B-29, not originally, but afterwards. And so just imagine doing a plug change on that. So those piston engines have actually got a limitation. And it was from this, the jet engine really took over. So when we had the original rotary engine going, that had limitations because of the weight of it going around. Then the radial engine, the complexity of it, and then of course the jet engine, which was relatively simple, took over from that. Let's go on to the next slide. This is the Rolls-Royce Merlin engine, which of course we're all familiar with the Spitfire and Hurricane. And it was a magnificent engine. 4 valves again. The valves are all vertical, which of course helps from the point of view of making the cylinders. Rolls-Royce car engines actually had the inlet at an angle and the exhaust on the top. And the Rolls-Royce car engine obviously was a little bit more complicated. But the Merlin engine started off around about 1,000 brake horsepower and ended up as over 2,000. And apparently they actually used the same crankshaft, so it must have been drastically over-engineered in the first place. Here you've got a situation where the piston has actually got a bit of a roll, a bit of a curve in it. So that gives you a little bit more combustion help. Also, most of the aircraft engines had a plug on either side, so that the flame spread went really from one side to the other. And so you've got complete combustion. You are looking at quite large pistons, of course, when you come onto something like this. The valves are also, of course, relatively small. The valve springs, rather, fairly short. And when we looked at the model engines, they tended to be very long. So we decided to follow full size and go for relatively short springs. Let's go on to the next slide. Silencers with 4-stroke engines are not so critical as with the 2-stroke. Two-stroke engine, especially of course the racing model ones that we have, and of course the motorcycle ones, have a tuned effect on it. You don't really get quite the same effect with the 4-stroke because you're forcing the gas out of the cylinder in the first place. So you're not reliant on the silencer pulling gas out of the cylinder. A couple of types here. One has got the top one has got absorbent type material around there, so that absorbs the noise. The one below has got various different chambers involved in it, and again that is much more suitable really from the point of view of a 4-stroke engine. The ones with the absorbent material tend to get clogged up with oil. Let's go on to the next slide. What is very important with any engine is to make sure that you get cooling on it. And you can probably see here that just below the cylinder itself, you can see the fins, and the air is actually pushed up through the fins, and it actually comes down through the bottom. This is there's a duct at the bottom of the cowl normally, and so that the airflow is actually pushed right the way through. They're getting good quality cooling. Let's go on to the next slide. Again, similar thing here. You've got a radial engine, and you've got blanking pieces between the cylinders, which stops the airflow going straight through and missing the cylinders. It is important because, again, it comes on to our model engines. And, you know, we tend to sort of stick an engine into a model and not think about the cooling side of it at all. But it is extremely important from the point of view of reliability and keeping cool. Let's go on to the next slide. We're now going back onto the model side of it. And this is Chris Foss with the Watt 4. And we joined him, I think it was 1984 at Sandown. and he put a laser 61 into a Watt 4, and that was really one of the starts of our sports sort of side of the engines. I'm going to go on to the model side of it, and then we'll go on to the actual design of the engine a little bit further on. So we're missing out a little bit. Let's go on to the next slide. That's dear old Chris. I won't say old because he's younger than I am. And this is a Watt 4, the Aqua Watt, a fantastic aeroplane, and they fly extremely well. That one had a laser 75 in it, and we flew that one, I think, at Sandown again. And that's an aeroplane which has stood the test of time, as of course the Watt 4 has as well. And you know, they've gone okay. You can still buy the kits. You can get them ARTFs, and they all seem to fly exceptionally well. Let's go on to the next slide. We've made laser 150 twin using the laser 75 cylinders. And Jeremy Shaw, Dr. Jeremy Shaw, said, what about making it into a 180 twin? And so we used the laser 90 components and made a 180 twin. And he had the two prototype engines, which he put into his Stranraer flying boat, which was one of the most iconic aeroplanes that I think I've ever seen. It would go across the water. It was relatively quiet. It would take off, and the water was running down the hull. And when it came past, you got a noise from the props, from the engine, and also from the wires. You could actually hear the wires singing. And that, to me, was an absolutely wonderful aeroplane. Let's just go on to the next one. This is the DH-86, and there are 4 180s in this. And you know, again, lovely large aeroplane, and with the 4 engines running, well, it sounded absolutely wonderful. Let's go on to the next one. With our advertising, we really didn't do much in the way of advertising, so our marketing really evolved around models. And this was Brian Taylor, and he put a laser 75 into a Spitfire and won the Nationals in 1985, I think it was. So that was our first win in competition. And if we go on to the next slide, this is Pete McDermott. He put a laser 90 into his Sopwith Snipe at that stage. And he again won the Nationals. I think that was the following year. So let's go on to the next one. Then we come again to Pete, who is a fantastic aero modeler and, you know, lovely guy. And he made a Sopwith triplane, and the laser 180, which Jeremy Shaw was using in the Stranraer, he used the 180 in the triplane. And the rules changed then because it meant you could have unlimited capacity for the engines. And so that's where the 180 really scored over the single cylinder engines, you know, being very smooth. McReeves had one in his Sopwith Camel as well. And so Pete won the World Championships in 1992 in Muncie in America. And that again was quite a remarkable achievement. And I'll always remember coming back in the aeroplane with Dennis Sumpson there, and he bought champagne for everyone. And it was a real euphoria, you know, to actually get a win there, because we won the individual, people won that, and we also won the team prize as well. Let's go on to the next. This is Max Merkenschlager, who again used our laser 180. And I do remember, actually, I think it was in Muncie, where I knew that he had been using castor oil, and the valve was getting clogged up. And I said to him, we've really got to take the engine apart and clean that valve over. And his wife, Gertrude, said, oh, we do not trust you. And we had a guy sitting next to me, he was watching me taking this thing, the engine to bits. And I said, my quality control manager. And he said, I'm the quality control manager for Ford of Europe. So that was a little bit scary in a way. But at any rate, we got it all going well. And Max won the World Championship in 1996, I think it was. Let's go on to the next slide. This is some of the detail actually of the models. And these scale models were absolutely amazing. If you go on to the next slide, we can probably see Pavel Fensel also won World Championships. And he actually had this model right from 1992 in Muncie. And he built an Antonov, which unfortunately crashed. And he brought this aeroplane back into service again and fitted it with a Laser 180 single. He is from the Czech Republic. Max Merkenschlager was German. And another little story actually was in Deelen, when the Germans team won the team prize, and they got onto the podium there, and the Dutch couldn't find the German national anthem. It was very strange. I think that was some real mistake, of course, in that case. Let's go on to the next slide. This is Andreas Luthi, and he made an Avro triplane, which is the one which is at Old Warden, and unfortunately it didn't have much more cooling. So I did suggest he cut a small hole in the front of the aeroplane, and which he did, and the engine did perform okay. And he again won the World Championship. I think that was 2000, I think it was. He then went on to building another aeroplane and has won virtually every championship since then. Not with a laser engine on that one, but a remarkable builder, and not only that, a remarkable flying as well. I think he came from the aerobatic world. If you get people coming from the aerobatic world, they can really handle these scale models extremely well. Let's go on to the next one. This is again a little bit of detail. Now this is a model, and when you sort of look at that sort of detail, however long does it take to make something like that? Absolutely remarkable. I think we've got a couple more slides. Let's try the next one. Oh yeah, that's me with the Manx Monarch, which was scaled up by David Boddington and built by Ken Swales from a 1950 aeroplane. We've had real fun trying to get it to fly. Andrew said, "Would you like to have a go with it?" And David unfortunately passed on, and so I didn't want to crash it, but we have flown it a number of times. And the thing which we can't seem to get over at the moment is a sort of Dutch rolling. But again, I find tailless aircraft are quite fascinating. And this thing's something like nearly 15-foot wingspan. Let's go on to the next one. This is going back an awful long way, and to the combat days. And as you can probably see, I've changed a little bit since that time. And the guy with me is Derek Woodley, who was with the Bald Eagles. And in the Bald Eagles, we actually ended up with Derek and a fellow called John Downey. And they both went on to fly Concorde. And Derek was one of the last instructors on Concorde. And this is where aero modeling has an influence on full size. And that's, I think, started him off actually on his knowledge of aircraft. I think that's the last of the slides. No, it's not. Oh no, sorry, losing track. This is the effect of castor oil, which was absolutely horrible. And as you can see, it's carboned up. If we go on to the next slide, this is a glow plug. Plug is very important, and the coils have to be kept in proper coil sort of fashion. That would be a Duff plug. I think, again, Barry will tell me a bit more about plugs, because I think you get through plugs at quite an alarming rate. And but with the laser, we seem to get them to last for for years. And one thing which was interesting, with the Laser 75, with the configuration of it, with the plug on the front, we could actually look through the exhaust port and you can see the plug. And if you watch it, it glows almost white hot. Absolutely amazing. Let's go on to the next slide. This again is where the plug has deteriorated because the platinum plating on there has become all pitted. And although the plug is in a good shape, it's not obviously much good. Let's go on to the next one. That's the effect again of castor oil. Nowadays, I just do not recommend castor oil in the fuel at all. And the synthetic fuels keep the engine in lovely clean condition. One of our club people, he had a steerman, and he was an ex-Navy pilot, and he logged every flight, and he'd actually achieved 213 hours running of the engine, and because we lent him an engine because I knew he logged everything, and we got it back, stripped it down. Hardly any wear at all actually on it, not noticeable, and he insisted on buying it back again, which it ended up in a couple of his Spitfires, I think. So the engines can live a long time. Let's go on to the next. This the cylinder head, and we'll go into this one in a little bit more details later on. Number of things on there. You can see the shape of the combustion chamber. We've got an inlet valve which is slightly larger than the exhaust. The plug is pretty central, and we did originally have the plug at an angle, which I think did have some advantages, but it had the disadvantage, of course, of connecting the plug. And quite frankly, it's easier to make the plug vertical from the point of view of actually machining it. We changed over there as well. Instead of having two little grub screws holding the silencer and the exhaust in, we made a clip arrangement so that the exhaust and the silencer just simply push in, and they're held by the clip. Most model engines are screwed in, and of course the difficulty on there is that if you cross thread it, you lose the whole cylinder head. So it's pretty useless then. The other little details on there. We've got collets holding the valve springs in, and you can see those at the bottom. There are four of those. Number of engines, when we looked at them, we used C-clips, which we knew tended to fail. So we went for the straight collet type fitting. Enya actually did in fact make theirs taper as a taper collet. The other thing which also we put on there, instead of using a one-piece combined valve guide and valve seat, which everyone else tends to be using still, we used separate valve guides. And the reason for that is that it gives a longer bearing surface on there, and so it means that the valves seat much more reliably. So those are the main parts on the cylinder head itself. And have we got any more? I forgot now whether we've got any more. No, that's okay for that side. But we can go on to the design of the engine. If we can go onto a larger screen, I've got some bits here to show. Fascinating things over the years. This was a petrol engine which we made using laser 90 parts, and a different cylinder head. It actually had a bathtub cylinder chamber, and we made in the bottom here a sump, so that it had a dry sump arrangement, and of course spark ignition, but it was just a simple spark ignition. And we made some of those for Cranfield University for their experimental use. This one here is a Merco conversion that a fellow Luton made, and that again has a little bathtub cylinder head, two valves on it, and that's the one with the remote plug. So we'll put that to one side. He had the valve gear at the back, and it all went into a box like that. Quite straightforward. That was, I think, the first cylinder head that we actually made. And again, you can, if I can turn it to there, you can see the shape of the cylinder head that we devised. And we haven't changed that really at all. But of course, everything has got much more sophisticated. That one is an early Laser 60 cylinder head. And what happened there was that we actually made valve seats and pressed those in. It was like a ring, made them out of phosphor bronze. But we found actually with the valves, which were stainless steel, it would actually wear the valve. And we then experimented by leaving out one of the seats, and that was the inlet one there. And we thought, is that really necessary to have, you know, this extra complexity? And so we then made it so that the valve actually seated straight onto the aluminium. And what we found on there was that the aluminium work hardens as the engine is run, and so very, very little wear actually takes place, in fact, on the valve seat. And that's where, you know, the engines can run for you know, basically hours. The cams, I should have, oh, here we are. Probably can't see it terribly well, but we made the engine with the camshafts at the back, and there's a drive from the crankshaft to the cams. Now, there are a number of reasons for doing it that way. One, of course, is that the crankshaft is straightforward. There are no gears or anything on it. The valves at the back do mean that the height of the engine becomes further back, which is much better from the point of view of the scale model. If you have valves on the front, it's quite tall. And so the laser engine is actually very compact. The valves themselves were designed, would you believe, on a Sinclair ZX81 computer. And older members will probably remember ZX81. And the program took nearly 3 minutes to go through. The reason for it is that we were plotting I'm just getting a couple more bits actually while we're talking. That's the valve, and that's the separate valve guide. I'll put that to one side, and I'll come back to that one in a minute. Little details that crop up. Originally, racing engines all said, oh, you need lightweight rockers because of the speed that it's operating on. So we made the rocker out of aluminium and put a pad on the end of it, and that was on the Laser 75. Then later on, we sort of thought full car engines have all got valve rockers which are made of steel. And so we started thinking about that. And in actual fact, that's a steel one. And when you think about the acceleration of that, opening up a valve, the valve spring is at its loosest really when it's sort of fully, when the valve is closed. So when you start pushing that down, the pressure gets higher. And of course, if you think of that as momentum, you're pushing the valve down, and that's again gaining momentum. The same thing applies actually when it shuts. Most of the spring pressure is at the fully open sort of point. So that forces the acceleration on that. And so you're using the actual weight of the rocker to actually help in terms of closing and opening. So that's when we ended up by changing over to steel ones there.
Neil, while you're digging out some bits. We've got a couple of questions that came in very early, and I just thought if I can put these across, I'm sure you'll be able to cover it with your bag of tricks there. But one of them, it did make me smile. If I go on to the first question that came in 3 minutes into the talk, so somebody's very desperate to resurrect a laser 75 here. How do I clean my gummed up laser 75? And that was from John Bennett.
It's well, obviously it's been run again on castor oil. It's one hell of a job. You do exactly the same thing as you do with the two-stroke engine. So I can probably ask Barry on that one in terms of cleaning gunge and castor oil from an engine.
Oh.
Have you got any?
It's some quite vigorous cleaning with things like paint strippers and what have you, Neil. In our engines, we actually abrade off. We have to run castor oil. It's in the rules, and we end up actually abrading it off the pistons.
There we go.
Yeah, I mean the laser 75. We stopped making that, I think, in 1990. So that engine is going to be at least 30 years old. I know if you sent it back probably to John at the factory, he's got a big box of them. So in other words, buy a new one.
Just while we're on castor oil as well, Will Simpson, I'm just trying to segue these. Any benefit to using a tiny percentage of castor oil in fuel to prevent bearing rust, or just get better bearings and use 100% synthetic? ?
No, I advocate 100% synthetic. Forget the castor oil completely.
Brilliant.
You know, castor oil was fantastic during World War I, and you know, obviously the effects of castor oil kept the engines running very well. I think it kept the pilots pretty well oiled as well. But nowadays, you imagine putting castor oil into your car. You know, the modern oils are absolutely fantastic. You know, so you use that, and in a way, actually, I'm surprised that with the racing engines, you know, why not go on to modern oils?
I think Barry.
Yeah, the problem is if you're in international competition like an FAI competition, what oil do you mandate? And it's proven over time that it's easier to control the fuel with castor oil, but there are a lot of downsides that particularly would affect your kind of running. You know, the castor oil engine needs a lot of cleaning. You have to be right on top of it. But it's for those reasons, Neil, really. So for boat racing and model car racing, that kind of thing, where the fuel's unlimited, then you use synthetic oil.
Yeah, to me, it's a backward way of going about things, and the development of engines and you know, comes on to using modern materials. And you know, my feeling is that the rules should probably, you know, change so you use what is available and the modern stuff. You know, you're not actually improving anything by using these old-fashioned oils. But that's by the by. You can't do anything about it unless the FAI agree to it. And I can see your point about controlling it. Now, one of the things, of course, with fuels, again, I've always kept to a low or no nitro. One of the things is that it's expensive. The other thing is that nitro does tend to corrode engines, you know, reasonably well. And if you can design an engine, which of course the FAI speed engines, I think they run on straight cast methanol. Yeah. So you know, it can be designed that way, but it does make the engine a much easier thing to design if you put nitro through it. And that was actually a mistake that we made in the first place, because you know, we suggested using straight caster fuel, and of course if you compare that with an engine which is running on, shall we say, 10% nitro, you're not going to get the same performance out of it. And so our engines were originally criticised a bit because of the lack of performance. And really, it was lack of nitro, which was the main problem on that. But we run now actually, well, I run actually on 10% oil, and I think we could actually I could drop that down further. One of the things which we did with the larger engines, with the piston, that's a piston of a laser 180 or something like that. We actually have 2 rings on there, and the lower ring, there is a hole drilled through. So we're using that lower ring as an oil control ring. And so that basically shoves oil into the crankcase. Another thing which also I tend to be doing now, actually, that's to block off the breather. So again, you think of a car, you wouldn't have a breather which chucks out oil. So keep the oil into the bottom end of the engine, and some of it will go back through. We're still using, obviously, the low pass oiling, but why chuck oil out from the crankcase?
Neil, we got a couple of other good questions here. How often do valve clearances need to be checked and adjusted? One that's from Richard Grimshaw.
Sorry, I didn't get that.
How often do the valve clearances need to be checked and adjusted?
When you feel like doing it.
Okay.
It's not, it isn't critical.
A question from Peter Brett. Now, I know Peter Brett pretty well. He worked at Castrol. He was a development guy at Castrol.
Yeah.
How is the camshaft valve gear lubricated? How does the oil get through to that area there?
Well, first of all, of course, we're looking at low pass on the piston, getting oil into the crankcase. So that's the first thing. Then in the on the cam, if I can, no, I don't think we can really sort of see there. There is actually a groove put in to the cam follow there, so you can get oil going back through that way. But you also get oil going in through the piston. If the engine is inverted, you'll find that the cylinder, the rocker cover will fill up with oil. And we had a case actually again there. A fellow in Austria wrote in the magazine about putting a vent on the rocker cover to drain the oil out from there. And we ended up with a few engines seizing up. Pointless chucking oil out. And so you do get oil actually going down through the pushrod covers and into the camshaft, onto the cams. Another little point, which I thought I brought one. Yeah, cam. That's actually a cam follower, and again we tend to have a foot on our cams, which again tends to follow the full size practice, because as the cam goes over it, it is smoother if you've got a foot on it like that, as against simply going into into a point. So again, we followed full-size practice on that.
Neil, you often refer to full-size practice. I remember that way back in that talk in Portsmouth. You were talking about full-size practice there. Would you have ever liked to have gone to a proper sump lubrication rather than this kind of pseudo 2-stroke fuel used in 4-stroke engines?
Yeah, well, it's simply a matter of complexity. Because if you had a dry sump, who was it now? One of the manufacturers actually did have one, but they were still putting a bit of oil through the fuel as well. No, if you're flying an engine which is aerobatic, then you've got to have a different system on it. And we did, of course, as I said, with that, we actually made a sump system on that. But again, it's simplicity, and also, of course, dare I say, making things easy for the modeler. You know, if you're relying on them filling up a separate sump, you know, when they go flying, it ain't going to happen, and so we're going to end up with engines sort of seizing up. With a petrol engine, you know, again, that's something which I'm running a couple of engines which I converted to petrol, and that again is using the blow past, you know, system, two-stroke there. And it works fine. With petrol, again, you've got the weight of the battery, you've got the weight of an ignition system, and it really is not relevant until you get you know, to a larger engine.
Neil, can I change the subject very slightly? Stuart Williams asked a question here. He's got a quarter scale SE5A, yet unflown. It's a dry weight of 22 pounds, and it's powered by a Laser V200. What make and size of prop would be the best to use on the model for scale-like flying? And he's saying thank you already because he knows you're going to answer this.
Well, you'll probably find something like an 18.6 would do quite nicely there. And again, I'm not going to sort of promote any particular type of or make of prop. You know, people get their own ideas, and you know, so I would not really want to get involved in particular makes of propeller.
There you go. Perfect. Thank you. Chris Walby, has Neil experimented with two-stroke bottom end and four-stroke top end type designs?
Well, like the YS. No.
No. There we go. That's good because we're getting through these questions because we're in overtime at the minute. We're all enjoying ourselves, but we are conscious that the questions are coming in. So I think the yes and no's are doing well at the moment. Martin Harris, most engines that I've had dealings with use longer duration, faster opening cams, the inlet side. I've noticed the laser engines seem to have a shorter duration on the inlet. What was the reason behind this?
Well, we want an engine which is not just simply getting maximum power out of it. We want one to have a wide torque range, one which is easy to handle, which will start well and will run you know, well. If you have you know, wild cams, it does make the engine more peaky, and it makes it more difficult from the point of view of reliability. So I'm looking for a general modeler's engine as against a racing, you know, engine. And longevity. Now, yesterday I was out flying a Majestic Pager with a 1987 Laser 75 in it, and running absolutely fine. Another fellow was doing the same thing as well, same age. So the engines can, you know, looked after, and provided they're not bunged up with castor oil, you know, can run for literally hundreds of hours, and they are designed really for sport and scale. With a scale engine, you go out onto your competition flight, you do not have a chance to tune the engine every time. It's got to just go, and that's what we're aiming for. You do find people who do tend to play around with needles, and you know, every time they fly, they're twiddling around, and not necessary.
Last few questions. One of them, and I think this is the last thing we'll take, Barry, on castor oil. But I had to smile at this. Stavros suggests that some years back he used biological washing powder to remove castor oil and gunge. Barry's nodding, so he's obviously tried Persil as well. So there we go. We'll just fill that one in. Tom has asked, is there any reason why glow plugs can't have the filaments renewed when they become useless?
Well,
it costs more to renew it than it would to make new ones.
It's not really worthwhile unless you're going through a lot of glow plugs. I mean, in racing, people do wind their own plugs and weld their own plugs, or even make their own plugs. We've just started making our own plugs now. But really, I think, like Neil said, if the engine's running well, the plug lasts a long time. You agree with that, Neil?
Yeah, I mean, one of the problems we had right in the early days was dear Ben Buckle, and he was having real troubles with his engine running there. And what was happening there was that he was starting the engine, and running it up to full power with the glow plug connected. And as I mentioned previously, looking down the exhaust ports, you can see then that the plug goes absolutely white hot and destroys the plug. And so basically every time you're starting running the engine, you're destroying a plug. So that is another important thing. Always take the glow plug off as soon as you can, and don't take it up to full power. It's probably running on full power, which you're, with your pylon races, those plugs are going absolutely white hot.
They are,
and you can't do anything about it because you're aiming sort of for the power, and that's that's fine.
But Barry, just before we obviously getting close to needing to close now. We've got 6 questions. We'll I think we've got 7 questions. I think we're going to stop at 7 now, because otherwise, I mean, we can always ask Neil back for another session at some stage. We'll give Neil a chance to have a glass of water. Next week, can you remind me? Sorry, I didn't look this up before we started.
I will.
Sorry, I've left you in a spot there just to.
Yeah, no, that's okay. I can. I'm used to being in a spot.
While you're
next week we have aviation toys. Vincent from Holland talking about the Rookie.
Fantastic.
Complete another sort of end of the spectrum. We're talking there about it's a little electric capacitor model. Flies great. And he's involved in an education program at CM, as you know. That'll be interesting.
F5J as well. He'll probably talk about, will he?
Yeah, he I guess so. But the thrust of the talk is the Rookie, which is also the BMFA 100-year centenary model as well. Brilliant.
Thank you, Barry. Right, Neil, let's do some yes and no's, I think, on these, or some very brief ones. There's now 8 questions. That's what we've got to do. We'll work through it. Neil, do you harden the cylinder? From Dennis Coe.
The cylinder on all the engines now is plated with a material which is nickel silicon carbide, and that's a cylinder, for example, and it's plated direct onto the aluminium, which gives, of course, excellent heat transference from the combustion chamber into the cylinder. The problem with it is that it's very expensive, and I think we're the only company that's actually doing it with that. Sato, of course, tend to chrome plate their engines. But all the Formula One racing engines, they all use this nickel silicon carbide, as do most of the expensive cars like Porsche. It was, I think, developed by Mahler in Germany, and there are 2 different types. One is electroplating, which is what we use, and that puts on quite a thickness of material. Some years back, OS tried to with electroless plating, which only puts on a very, very thin coating, and that tends to wear through. So that is the material we use. But as I say, it's very expensive to do it, but it's very hard. It does not wear, and of course, we're using piston rings on there, and very, very little wear takes place. Sure. But again, one of the things, it's like with the crankshafts, we use, I think it's EN36, it's a racing type high tensile steel, and we don't get crankshafts breaking. What we don't want is for engines to come back with something that's broken. And
what steel are you using, Neil?
I think it's EN36.
Yeah.
Which is nitride hardened, I think, at the end of the day. Yeah, so that is the way that we tend to look at things. Okay, it's more expensive. We decided right in the first part that we had to sell direct, just like Oliver Tiger. And that he was my hero, actually, John Oliver. And selling direct means that we've got control over what's happening. We can talk to customers. We can change anything if necessary. if we do find there is a fault somewhere along the line. But of course, there isn't margin to go through the trade. And, that is the main problem. Well, it's not a problem, but, we would have to produce an awful lot more engines to be able to go through that side. And I think, we probably are doing the right thing now by going direct, because I think so much now is actually going direct. One little thing, actually, that our original pistons, if I can show you, was that shape. And we still use that on a smaller engine, and it works extremely well. We make these actually from aluminium, and I think it's a Rolls-Royce spec that we use on there. It's not a high silicon as people tend to think of pistons, but what it is, it's a very high tensile steel, aluminium. Sorry. Carburetor, by the way, was an interesting one as well, because we originally used Super Tiger carburetors. We couldn't get them eventually, and so we changed to Irvine carburetors. Irvine stopped manufacturing, so again, we make our own carburetor, and we've incorporated some slight changes on there. One is the throttle stop screw, which is on there. That's hardened steel. The Irvine one tended to wear, and so you ended up by getting slop on there. And another little thing which I'm using on my petrol engines is a plastic extension piece on here, which of course stops the heat going through from the engine to the carburetor. But a lot of little modifications, of course. I mentioned actually about using the clips, because it's so simple, and it works very, very well. And of course, it means you can turn the carburetors around, and the silencer that comes standard. Well, that was another thing, actually, putting everything on the back of there, including the silencer, means that you can get most of it within a cowl. I got a Horizon Piper Cub, and that had originally had a Sato 120 put in it, and there was a hole in the bottom for the cylinder head to go through. There's a hole in the side there for the silencer to come through. I filled in all those holes, and the Laser 150 or 155 goes straight into that cowl without anything showing at all. And so it makes it very much more complicated, very much simpler rather, by doing that. Any more questions?
Yeah, well, we're going to take two more questions, and they're both actually very similar here. Paul Lewis and Nigel Castle both ask, are Laser developing petrol engines?
Well, they have done, actually. I'm not involved with that side of it at all now, but I'm doing it from my own point of view. And for the past, 3 years, I suppose, I've been flying an extra watt, one of the with a Laser 180 petrol engine in it, and it runs fine. But I don't know about whether any more development has taken place. Certainly, there have been petrol engines made, and with a pump, a gear pump, built onto the back. And I know, being a member of the old Warden Club, one of the members there, he's actually got one, and it runs absolutely fine. But whether it's going into production, full production, I don't know.
Neil, I think we're going to have to save some of the questions for another time with you, if we can gladly get
I'm happy to carry on if you're.
Well, we people are leaving the room, which is understandable. A lot of people come back and spend an hour and 20 minutes, and then they've got other duties, and dinner often gets in the way. We know that. But what I want to say is as well, there's about 40 or 50 people here have just written, thank you very much for the workshop. Absolutely brilliant. Great talk, Neil. My 75 is indeed 30 plus years old. Thank you, Neil. A very interesting talk on laser engines. Great diagrams and explanation on how they function. Ditto that. Will your flat twin become commercially available? Say that for another day, probably, I think. Thanks, Neil. I enjoyed the history journey and the explanations for your design choices. Frank Marshall, what a treat to hear from a modest, knowledgeable but experienced and down-to-earth gentleman without bias. So there you go. and these go on. I mean, I'm literally flicking through. Great talk, Neil. You held nearly 280 people up until 15 minutes ago. And
well, thank you. Thank you for inviting me, and thank you for everyone using laser engines and for watching the show. And I shall continue flying my engines, and I enjoy the modelling side of it. I've got something like 24 aircraft which are in flyable condition of various different types. Yesterday I was flying a model called a laser beam, which was the subject of RCM&E back in 1987, and it was designed by Brian Peckham, and I've got the original one that Brian made. Unfortunately, Brian died actually 2 years afterwards. I don't know if scale people remember Brian, but he was a very good modeler. I've got models which were built from David Boddington, who I have fantastic respect for. He was a wonderful guy, and he tended to use Ken Swales. I've got a Supermarine lookalike type model that Dave did, and we flew this down at Calshot about 10 years ago for Britain's favourite machines. And again, that was quite interesting because of that was actually on television, and it was interesting seeing the way the things were being done. And I look forward to a few more years of modelling. And thank you very much indeed for inviting me on. I've enjoyed it.
It's all our pleasure. Don't worry. We just facilitate this for everybody else. And since you're finally summing up, there's just been another 15 people have just said thanks, Nick. Wonderful talk, wonderful engines, love the ones. Yeah, fascinating presentation, enjoyable. I mean, I'd probably need an hour to go through all of these, but it's been one of the best responses I think we've ever had, and that really sets the bar massively high. So look, Neil, thank you very much indeed. Barry, you can sum up, please.
Neil, great talk, really appreciate it. I hope that we can get you back maybe in the autumn, probably more towards a questions and answer session. Maybe we'll get those questions submitted so that you can sort of analyse them and give really thorough answers. There's all kinds of ways that we can collect those questions up. So yeah, I really appreciate it, Neil. Great talk.
I would actually like to mention that Laser Owners group has started up on Facebook.
Yes.
So you can look at that one. And we've got Model Air coming up at Old Warden, so please come along to that. And I'll be down at Wings and Wheels again in June.
Okay.
July.
Great.
So we look forward to seeing everyone.
Yeah.
Thank you.
Okay.
Let me stop the recording.
Yeah, stop the recording. Yeah.